You know what keeps me up at night? The thought that on one summer evening in 1977, we might have actually heard someone calling to us from across the galaxy. And then, just like that, the signal vanished into silence, leaving us with nothing but questions and that haunting possibility that we just missed the most important phone call in human history. For almost 50 years now, scientists have been trying to explain what happened that night at the Big Ear Radio Telescope in Ohio, and here's the thing that really gets me. Every time they think they've figured it out, something doesn't quite add up. So why am I telling you about this now, in 2025? Because right now, we're in the middle of what some are calling a new golden age of the search for extraterrestrial intelligence. We've got thousands of newly discovered exoplanets, some potentially habitable. We've got new telescopes scanning the skies with technology that would have seemed like magic back in the 70s. And yet, that one mysterious signal from almost half a century ago still stands as one of the most compelling pieces of evidence we've ever found. It's a case that refuses to be closed. Let me take you back to August 15, 1977. It's a Monday night, just after 11 in the evening. The Big Ear Radio Telescope in Delaware, Ohio, is doing what it does every night. Automatically scanning the sky, listening for anything unusual. Now, this telescope wasn't your typical dish antenna. Picture a massive rectangular structure, about the size of 3 football fields, filled with reflective panels. It looked more like a giant's parking lot than what you'd expect a telescope to be. But this beast was designed for one specific purpose: to catch radio waves from deep space. That night, a volunteer astronomer named Jerry Emmon was going to come in the next day to review the computer printouts. You see, back then, we didn't have fancy digital displays or real-time alerts. The telescope's computer would print out columns of numbers and letters on continuous paper. Each character represented the intensity of radio signals the telescope detected. Most of the time, it was just ones and twos, the quiet hum of cosmic background noise with nothing particularly remarkable in the data. But when Jerry sat down with his coffee and started looking through the printouts from the previous night, he saw something that made his heart stop. There, in the middle of the page, was a sequence of 6 symbols that seemed impossible. The numbers and letters showed a dramatic spike in signal intensity unlike anything the telescope had ever recorded. The pattern jumped from baseline noise to the maximum level the system could measure without going off the charts. Jerry was so stunned that he grabbed his red pen and circled the entire sequence. In the margin, he scribbled one word that would become the most famous annotation in the history of radio astronomy. That single exclamation of amazement gave the signal its name and perfectly captured what he was feeling in that moment of discovery and disbelief. But what made this signal so special? Why did Jerry react that way? Well, let me break down what made the wow signal stand out from every other blip and beep the Big Ear had ever recorded, because once you understand these details, you'll see why this thing has haunted researchers for decades. First, the frequency. The signal came in at 1320 megahertz, which is right around 1420 megahertz when you account for the Doppler shift from Earth's movement. And here's why that matters, why this detail sent chills down Jerry's spine. That frequency is right in the middle of what we call the hydrogen line. It's a natural frequency that hydrogen atoms emit, and hydrogen is the most abundant element in the universe. Back in 1959, 2 physicists named Giuseppe Cacconi and Philip Morrison published a paper suggesting that if any intelligent civilization wanted to send a message to other civilizations, they'd probably use this frequency. But because any civilization advanced enough to build radio telescopes would know about hydrogen. It's like the universe's universal language, the cosmic equivalent of leaving the porch light on. Second, the signal was strong. Really strong. It was 30 times louder than the background noise. To put that in perspective, imagine you're in a quiet library and suddenly someone starts shouting at the top of their lungs. That's the kind of jump in intensity we're talking about. Third, the signal had a very narrow bandwidth. It wasn't spread out across a range of frequencies like natural cosmic phenomena usually are. It was focused, precise, almost like someone had carefully tuned a transmitter to that exact frequency. And fourth, the signal showed the exact pattern you'd expect from something coming from deep space. As the Earth rotated and the telescope's field of view swept across the sky, the signal grew stronger, peaked, and then faded away. The whole thing lasted for 72 seconds. The maximum amount of time the big ear could observe any single point in the sky before the Earth's rotation carried it out of view. Now here's where things get really interesting and honestly really frustrating for everyone involved. Jerry and his colleagues immediately realized they'd found something extraordinary. So what did they do? They pointed the telescope back at the same spot in the sky. They waited for the Earth to rotate back around. They searched and searched, night after night, week after week. And they found nothing but the same quiet emptiness that fills most of the cosmos. That region of the sky, which had screamed at them with that powerful signal, was now as quiet as everywhere else. The signal never repeated. Not that night, not the next week, not in the 48 years since. And that's been the maddening mystery ever since. So where exactly did this signal come from? The Big Ear's design allowed them to narrow it down to a small region of sky in the constellation Sagittarius. We're talking about an area that's about 2.5 times the width of the full moon as seen from Earth. Within that patch of sky, there are no obvious candidates. No nearby stars that stand out as particularly interesting. The closest star system in that direction is more than 200 light-years away. Which means if the signal came from there, it would have been transmitted around the time of the early 1800s. Long before humans even understood what radio waves were. And think about this. If an alien civilization sent that signal our way, they'd have to aim it with incredible precision. Space is vast, and hitting Earth across those distances would be like trying to hit a specific grain of sand on a beach from a mile away while blindfolded. It's not impossible, but it requires purpose, planning, and technology we can barely imagine. But maybe, just maybe, it wasn't aliens. Maybe there's a perfectly natural explanation. And over the years, scientists have proposed several. Let's walk through them, because each one teaches us something important about how we investigate these mysteries, and honestly, each one shows just how hard it is to definitively explain something that happened once and never again. The first and most obvious explanation is that it was just Earth-based interference. Maybe a satellite, maybe a military transmission, maybe even a passing airplane. But here's the problem with that theory. The Big Ear was designed to reject signals from Earth. It had two separate receivers, or horns, that looked at slightly different patches of sky. If a signal was coming from Earth-based interference, both horns would detect it. But only one of the Big Ear's horns picked up the WOW signal. The other horn, looking at a slightly different area just 3 minutes earlier in the telescope's rotation, detected nothing unusual. That strongly suggests the signal came from space, not from our planet. What about a secret military satellite? Some people have suggested that maybe a classified satellite happened to be passing through the telescope's field of view at exactly that moment, and its signal just happened to be on the hydrogen line frequency. It's possible, sure. But there are problems with this explanation too. First, the signal's strength and characteristics don't match what you'd expect from a satellite transmission. Second, the government would have to have been keeping a satellite secret for almost 50 years, even from the scientific community. And third, the timing would have to be incredibly unlucky. What are the chances that in the millions of observations the Big Ear made, a secret satellite just happened to pass through at the exact moment it was looking at that particular spot in Sagittarius? Then there's the Comet hypothesis. This one gained some traction a few years ago, around 2016 or 2017. Two researchers, Antonio Paris and Evan Davies, proposed that the signal might have come from a comet. Specifically, Comet 266P by the name of Christensen. They suggested that comets can produce radio emissions at the hydrogen line frequency because they're surrounded by massive clouds of hydrogen gas. When the paper came out, a lot of media outlets jumped on it, declaring the WOW signal mystery solved. But here's the thing, and this is where scientific skepticism really matters. Most experts in the field weren't convinced. The problem is that comets generally produce very weak radio emissions, nowhere near the intensity of the WOW signal. Plus, comets move slowly across the sky from Earth's perspective. If a comet had been the source, the telescope should have picked up that signal again on subsequent nights as it continued tracking. But it didn't. The comet explanation has some interesting elements, but it doesn't quite fit all the facts. Another natural explanation involves something called interstellar scintillation. This is basically when radio waves from a distant source get bent and focused by clouds of plasma floating in the space between stars, kind of like how a magnifying glass can focus sunlight into a burning point. Maybe, the thinking goes, there was a relatively weak but constant radio source out there, and for just 72 seconds, conditions aligned perfectly to amplify its signal as it passed through some cosmic lens. It's a neat idea, and scintillation is absolutely a real phenomenon that we observe. But again, the specifics don't quite work. The signal was too strong, too focused, and too perfectly on the hydrogen line frequency. Natural sources of radio waves tend to be messy, spread across multiple frequencies. The WOW signal was anything but messy. So if none of the natural explanations quite fit, does that mean it was artificial? Does that mean it was aliens? Well, here's where we have to be really careful, and this is the part that drives some people crazy. As scientists, we follow a principle that's been around for centuries, often called Occam's razor. The basic idea is this: when you have multiple explanations for something, the simplest one that requires the fewest assumptions is usually correct. An alien civilization broadcasting to us requires a lot of assumptions. It assumes intelligent life exists elsewhere. It assumes they developed technology. It assumes they decided to broadcast into space. It assumes they aimed at Earth, either deliberately or by chance. It assumes their signal reached us at exactly the right moment when we were listening. That's a lot of ifs stacked on top of each other. But here's the flip side, and this is what keeps me coming back to this mystery. The universe is unimaginably vast. Our galaxy alone contains somewhere between 100 billion and 400 billion stars. Many of those stars have planets. We've discovered thousands of exoplanets just in our tiny corner of the galaxy, and many of them are in what we call the habitable zone, the region around a star where liquid water could exist on a planet's surface. Life emerged on Earth relatively quickly once conditions were right. If that's typical, if life arises wherever it can, then statistically, we should not be alone. And if we're not alone, some of that life might have evolved intelligence. Some of that intelligent life might have developed technology. And some of those technological civilizations might be trying to communicate. This is the heart of what's called the Fermi paradox, named after physicist Enrico Fermi, who supposedly asked this question over lunch one day. If the universe is teeming with life, if intelligent civilizations are out there, then where is everybody? Why haven't we heard from them? Why haven't we found clear evidence of their existence? One possible answer, and it's the one that gives me chills every time I think about it, is that we have heard from them. Just once. For 72 seconds on a summer night in 1977. And then, for reasons we can't understand, they stopped. Maybe they're broadcasting in a pattern we haven't figured out yet, like a lighthouse that sweeps past Earth once every few years or decades. Maybe they only transmit occasionally, and we'd need to listen for decades or centuries to catch them again. Maybe something happened to them, and that signal is all that's left, an echo of a civilization that's no longer there. Or maybe, and this is the possibility that some scientists find most frustrating, maybe it really was just a weird natural phenomenon or a technical glitch that we'll never fully understand. Here's what really gets to me about the WOW signal, and why I think it matters even if we never figure out what caused it. It's not just about whether it was aliens or not. It's about what it represents. Think about Jerry Emmons sitting in that room, looking at those printouts, and suddenly seeing something that shouldn't be there. In that moment, he felt what every scientist dreams of feeling. That jolt of recognition that you've stumbled onto something truly unknown. Something that might change everything we thought we knew about our place in the universe. And then, just as quickly, it slipped away. It's like catching a glimpse of something incredible out of the corner of your eye, and when you turn to look directly at it, it's gone. Was it ever really there? Did it mean what you thought it meant? The search for extraterrestrial intelligence has changed a lot since 1977. We now have projects like Breakthrough Listen, which uses some of the world's most powerful radio telescopes to scan millions of stars. We have arrays like the Allen Telescope Array, specifically designed for SETI work. We're not just listening for radio signals anymore. We're looking for optical pulses, infrared signatures, even hypothetical megastructures that an advanced civilization might build around their star. The technology and the scale of the search have exploded in ways that the Big Ear team couldn't have imagined. And yet, we haven't found another wow signal. We haven't found anything quite like it. Some people find that discouraging. If there are aliens out there trying to communicate, why has it been so hard to hear them? But I think about it differently, and maybe this perspective will resonate with you too. The universe operates on timescales that make human lifetimes look like eye blinks. We've only been seriously listening for about 60 years. That's nothing. Less than nothing on cosmic scales. A civilization across the galaxy might broadcast for a few decades, then pause for centuries. Or they might be using communication technologies we haven't even thought of yet. Imagine trying to explain the internet to someone from the 1800s. That's probably how far behind we are in understanding how truly advanced civilizations might communicate. Or they might be there, right now, broadcasting away, but we're looking in the wrong place or at the wrong frequency or in the wrong way. The wow signal reminds us of something important, something I think we need to hear more often in our age of instant answers and quick explanations. The universe is under no obligation to make sense to us on our schedule. It doesn't care about our need for closure or our desire for simple answers. It presents us with mysteries, and it's up to us to keep asking questions, to keep looking, to keep listening, even when the answers don't come easily or quickly. Maybe we'll never know what caused that signal. Maybe it'll remain one of those tantalizing unsolved puzzles, a reminder that there are still things out there that can surprise us, that can make us question what we think we know. Or maybe, just maybe, someday we'll pick up another signal. Maybe it'll come from the same spot in Sagittarius, or maybe from somewhere completely different. And when we do, when that moment comes, we'll have 48 years of advances in technology and understanding to help us figure out what we're hearing. Until then, that printout with Jerry Emmons' red scribbled notation sits in the archives. A monument to a mystery. A reminder that on one night in August 1977, something reached across the void and touched us. Whether it was a voice calling out from another world or just the universe playing tricks on us, we may never know for certain. But the fact that we're still talking about it, still debating it, still searching for answers nearly half a century later tells you something profound about the human spirit. It tells you that deep down, we believe there's something out there worth finding, something worth listening for. And maybe that hope, that curiosity, that refusal to stop asking questions is what makes us worthy of eventually getting an answer. So here's my question for you, and I really want to know what you think about this. If the wow signal really was a message from an alien civilization, and they're still out there, still broadcasting into the cosmic darkness, what do you think they might be trying to say? Are they calling out hoping someone will answer back? Are they warning us about something we can't yet see? Or are they simply saying what every intelligent being wants to say into the vast emptiness of space? We exist, we are here, we are alive, and we're reaching out because we hope we're not alone. Let me know in the comments what you think. And if you could send one message back to whoever or whatever sent that signal, what would you say to them?